Hi, my fellow friends. So we are from Math Balance section number 3. We are from team number 5, which consists of Li Chao, Kidengi, Chiviate, and me, Joshua Li Junjin. So in this video, we are going to present our team assignment 1, which is question 11. So question 11, the unit processes and their corresponding stream as described in the table below are used to produce a biomass wet solid that is to be used in the production of drugs from biomass solution. So this is the table given. For question A, based on the description in table 1, construct and label the process flow diagram completely by combining 15,000 lbm per hour fresh biomass solution, which contains 30% biomass, with the filtrate from the filter, which is recycled. And then this combined stream is fed to the evaporator. For question B, by assuming the ratio of fresh biomass solution fed to biomass solid, bio in the filter cake is 4, determine the 1. First step of balance you would use to start solving this problem and why. 2. Flow rate of water evaporated and the composition of biomass solid, bio, and solution in the filter cake. And 3. The flow rate of recycled filtrate. So, for question A, we need to construct and label the process flow diagram. So, by referring to our table, we can conclude that the first unit process will be the evaporator, since our feed is the fresh biomass solution. Then the second one will be the crystallizer, and then the filter as the last one. So this is our process flow chart or process flow diagram. The basis will be the 15,000 lbm per hour of fresh biomass solution, and W will be the water, solid biomass will be bio, and solution will be S, which is water plus the bio. So for the 15,000 feed, first will be fed into the evaporator, and two output is produced. First will be the M3, which is the concentrated biomass solution, and M2 will be the water evaporated. The concentrated solution is then passed through the crystallizer to form a mixture of biomass, pure biomass solid, and also biomass solution. So M4 will be the mass flow rate for the pure bio solid, and M5 will be the solution. The mixture is then fed into the filter to produce two output, the filter cake and the filtrate. So for the filter cake, it consists of pure biomass solid and also the biomass solution, which M6 will be the pure biomass solid and M7 will be the mass flow rate for the solution. And then for the filtrate, there's only consists of the solution, the biomass solution, and then the filtrate is then fed back to the evaporator.
So now I'll be explaining about the first Roman number of question B. So how do we know which boundary should we choose first in order to solve the problem? So we can use DOF analysis to find the boundary that is suitable for us to solve the problem. So the one that gives 0 DOF, it means it can be solved. So we can see the first one, boundary A, overall system. We have 4 unknowns, which are M2, M6, M7, and X3. So there are only 2 material balance, which are bio, it means biomass solid, and then W stands for water. So there are 2 process specs. The first one is ratio, given by the question saying that ratio of fresh biomass solution fed to biomass solid in the filter cake is 4. So it's given by a question. And then the next process spec is this composition of the solution are the same. So what does it mean? We can look at the process flow chart. So we know that at the end of the boundary A filter, you can see at the filter cake there are X3. So the composition of the solution is the same as the filtrate. So why do we say so? Because in the filter, we doesn't produce or release any chemicals or materials. So obviously the composition of the solution are the same. So in the end, 4 minus 2, we get 0. So 0 DOF, it means it can be solved. So next we move to the next boundary B. So there are 3 unknowns, M1, M8, and X1. And there are 2 material balance, which are bio and W. So 3 minus 2, we get 1, so it cannot be solved. So next boundary, which is the boundary C evaporator. So there are 4 unknowns, M1, M2, M3, and X1. And then there are 2 material balance, which are bio and W. So 4 minus 2, we get 2, so it cannot be solved. So next boundary is boundary D, crystallizer. So there are 4 unknowns, M3, M4, M5, and X2. There are only 2 material balance, which are bio and W. So 4 minus 2, we get 2, it cannot be solved. So the last one is the boundary E, the filter. So there are 7 unknowns over here. So which are M4, M5, M6, M7, M8, X2, and X3. So there are only 2 material balance, which are bio and W. So there are 3 processing spec over here. So the first one is M4 equals to M6. Why M4 equals to M6? Because in the boundary E, which is the filter, we only filter to separate the solid and the solution. So M4 and M6 are the mass flow rate for the solid. So it doesn't produce any more solid in the filter stage. So obviously M4 is equal to M6. They are the same. So the solution composition are the same as the explanation at boundary A. In the filter, we doesn't produce or release any chemicals or material. So the solution in the filter cake and the filtrate are the same. So 7 minus 2 minus 3, so we get 2, it cannot be solved. So in conclusion, we use boundary A as the first step to solve the problem, as it provided 0 DOF, thus it can be solved. And then we use biomass balance to solve the problem, and thus we can know the composition of the total biomass in the filter cake, which will be explained in the next slide.
For question B2, we start from the boundary A. From the question given, we know that the process spec is the ratio of fresh biomass solution feed to the biomass solid in the filter cake is 4.0. So we can calculate that M6 is equals to 3,750 per mass bio per hour. Since the composition of solution in filter cake is same as the filtrate, so we can state that X3 is equals to 0.35 per mass bio per mass, and also 1 minus X3 will be equals to 0.65 per mass water per mass. Next, we perform the biomass balance equation, input equals to output. We calculated that M7 is equals to 2142.86 per mass bio per hour. And after that, we perform the total balance equation, input equals to output. We calculated that M2 is equal to 9107.14 per mass water per hour, which is asked in question B2. So next, the question wants us to solve for the composition in the unit of percentage of biomass, solid, and solution in the filter cake. So firstly, we need to find the composition of solid biomass. So we can take 3,750 divided by the total flow rate output, which is M6 plus M7, so we can get 0.6364. And for the composition of solution, we can take 2,142.86 divided by M6 plus M7, we can get 0.3636. And then we need to convert these two values into percentage. So finally, we will get the composition in filter cake of biomass solid is 63.64%, and for the solution is 36.36%.
Now we are going to talk about part B3. At B3, we need to find the flow rate of the cycle filtrate. However, for this part, we cannot use the boundary E, which is filter unit directly. Instead of, we need to use the boundary B first, which is crystallizer. This is because when we use the boundary E, which is filter unit directly, we will found that we cannot solve for the M average, the flow rate of the cycle filtrate. This is because the composition of the solution all are the same, which is the 0.35 and 0.65, and everything will be cancelled out when you're trying to solve for the MA. So we only can use the boundary T to solve for the M5, which is the flow rate of the solution that go into the filter. So first of all, we need to do the DOF analysis. There are 4 unknown, which is M3, M4, M5, and X2. And 2 material balance, which is the biomass and water, and 2 process specification, which is M4 equal to M6, as we know that the amount of solid that before filter and after filter will be the same. And also the composition in the solution are the same in the filtrate, because the filter cannot change the composition of the solution. And then we can get a 0 for the DOF. For the process verification, we can work the endpoint equals to 3750 pound bio per hour, x2 equal to 0.35 pound bio, and also 0.65 pound water. Then we need to use the total balance, which is the M3 equal to 3750 plus M5 as equation 1. Then use the biomass balance to get the equation 2, which is 0.4 times M3 equal to 3750 plus 0.35 M5, and then substitute the equation 1 into equation 2, and we can solve for the M5, which is 45,000 pound solution per hour. Then we only can use the boundary, which is the filter unit, to solve for the M8. For the DOF analysis, there are 2 unknown and also 2 material balance, and then is 0 DOF, which means that it can be solved. On the process verification, we can know that the composition of the solution, which is 0.35 pound bio and also 0.65 pound water. And then we only need to use one total balance, which is the total solution balance, to solve for the M8. There will be 45,000 equals to 2,142.86 plus M8, and solve for the M8, which is equal to the 42,857.14 pound solution per hour. And then this is the flow rate of the recycled filtrate. This is our final answer. That's all from us. Thank you.